Hey kiddos, it's Miss Gordon. I miss you guys so much. I love you guys so much and I cannot wait to see you guys. Unfortunately, according to our governor, we will not be able to see each other the rest of the school year, but I am still going to do whatever I can to make sure that you are prepared for fifth grade. Today, we're going to be watching a video via your Khan account, so please make sure that you log into your Khan account to see this video as well as assignments. If you are in Stanford, some of you do have new login, so please contact your teacher connect to get that new login. This video is going to be called adding fractions with unlike denominators. The denominators that we're going to be talking about are tens and 100s. These are going to be very specific and very important that we remember because they're getting us ready to go into our decimal unit. So let's watch this video. As I watch this video, I will be stopping it and asking you questions. Please make sure you're thinking about these questions as we move on and move forward to the video because they will help you answer your questions. Let's get this video started right now.
Let's see if we can add 3/10 to 7/100. And I encourage you to try adding these two fractions on your own first before I work through it. And I'll give you one hint. Right now it's very hard to add these fractions. You're adding 3/10 to 7/100. You're adding two different fractions with.
Why is it hard to add these fractions? What do you notice about those denominators that make it hard to add these fractions? Yes, if you said it's because they have two different denominators. You are totally correct. Give yourself 2 claps and 2 more. Nice job. Let's keep watching the video.
With two different denominators. So what I would encourage you to do is try to rewrite 3/10 in a way that it has 100 as a denominator, or so it's expressed in terms of hundredths, and then see if you can add them. Well, I'm assuming you've given a go at it. Let's see how we can rewrite 3/10, and I'll try to visualize it. So what I've done here, so this you could consider a whole, and this is a whole as well. And this whole is divided into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what would 3/10 look like? Well, it would be.
And before they get there, let me give you a little challenge. Try to solve this problem on your own. Try to solve this problem on your own. Let's see what happens when you try to solve this problem on your own. Take a few minutes. Go. Okay, let's bring it back. Some of you have already gotten the answer. That is super cool. Shout out to some of you who have that answer. Let's continue to watch and see if the answer that you got is the correct answer. Here we go.
1, 2, and 3 of the tenths. 3 of the tenths. Now, what would happen if you took each of those tenths and you divided them? If you took each of those tenths and you divided them into 10 more sections. So you're essentially taking each of those tenths and you're dividing them into 10 sections. Well, you have 10 sections and then each of them will have 10 subsections in it. So you're going to have hundredths. Then the sections are going to describe hundredths. So 10, let me write it this way, 10 times 10 times 10, you are then going to have hundredths, and 3/10 would be equivalent to how many of these hundredths?
Listen to what he said. 3/10 is equivalent to how many hundredths? So think about your initial fraction is 3/10, which is your if, times your with, which is your whole fraction. What is your whole fraction? This is going to equal your new fraction. So think about it. 3/10 times blank equals blank with the denominator of 100. What do you think? Let's see if he's going to get to the answer that you are thinking about.
Well, each of these tenths will now become 10. So you're going to have 10, 20, and let me color them in better. So that's 10, 20, and then 30 hundredths. So this part right over here.
3/10 is equivalent to how many hundredths? Look at how much he just shaded in.
This, let me get my tool right. This part right over here, this is going to be 3 times 10. 3 times 10, which is going to be equal to 30. 10 times 10 is equal to 100. So this is how we're going to change the denominator. Instead of thinking in terms of tenths, we're going to think in terms of hundredths. And now our numerator, 3 tenths is equivalent to 30 hundredths. So we can rewrite.
If you got 30 hundredths, say whoop, 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 whoop.
This fraction, we essentially multiplied the numerator by 10. We multiplied the numerator by 10. And we multiplied the denominator by 10, which didn't change the value of the fraction.
So if he multiplied the numerator and the denominator by 10, what's your whole fraction? Say it one more time. And how do you know it's your whole fraction? What do we know about whole fractions? Good. Let's keep going.
It still represents it still represents 3 tenths of the whole. So when you do that, you end up, we can rewrite this thing as 30 over 100. 3 tenths is equivalent to 30 over 100. We add that to 7 over 100, or another way of thinking about it, 3 tenths is the same thing as 30 hundredths. And we add that to 7 hundredths. Well, now we're going to have 30 plus 7 hundredths. So now we're going to have 30 plus 7 hundredths. 30 plus 7 hundredths. Or we could say that this is now going to be 37 hundredths. 37 hundredths. So this extra 7 that we're adding here, maybe I'll do this in, that's the same color. This extra sevenths, let me do this in a new color. This 7 hundredths that we're adding, that's going to be 1, 2, let me paint that in a little bit clearer. So that's 1, 2, so it gets us all the way to 7. Let's see, 1, 2, 3, so 7 hundredths. 7 hundredths is right over there. So let me get back to my pen. So that, this right over here is 7 out of the 100. So 30 hundredths plus 7 hundredths is going to get us to 37 hundredths.
Scholars, I want you to think about what must happen when you are adding fractions that have a different denominator. That's going to be the very thing you need to think about when we're doing adding fractions. What must happen when you are adding fractions that have different denominators? Take a moment to think about it. If you said that you have to find, the common denominator, that is very true. Think about what he did in the video to find that common denominator. He thought about the multiples. And once he thought about the multiples, he found the least common denominator, Nice job. Make sure you're thinking about that and you're using that as you are adding your fractions. You must have a common denominator, which common means the same denominator, before you solve the problem. Let's go to work.